Okay, exercise 10. First of all, ask for the EEF. Then ask for matrices that can be obtained from the EEF. And we'll talk about how those are obtained from the EEF after we get the EEF. All right, so let's find the EEF. So we're going to want to row reduce. Let me just put the identity matrix here. We're going to be adding this and then row reducing. And people made some mistakes with this, but let's just go ahead and do some row operations here. The first row we should divide by 3. So we get R1 over 3. And we'll get 1, 0, 2/3. And then here it becomes a 1/3, 0, 0. All right, now you can see that row 2 is going to stay the same. Let's take R2 over 2. And that will be 0, 1, minus 2. I'm sorry, and then 0, 1/2, 0. And then let's take minus R1 plus R3. And that will give me 0, 4, minus 8. And then, let's see, minus R1 gives me minus 1, 0, 1. All right. All right, now let's go ahead and do, for the next step, we'll take, for the next step we'll take all right, now for the next step we might as well simply take minus 4 R2 plus R3, because we know that that's going to take out these coefficients in this last row. So let me write it down here. It's going to give me 1, 0, 2/3, 1/3, 0, 0 on the top here. And then here I have 0, 1 minus 2. Now notice these guys are already in row echelon form. 0, 1/2, 0. And then the last one, when I do that, I'm going to get 0. So 1, sorry. I'm going to get 0, 0, 0. And then this is going to be minus 1, 0, 1. Okay, and then to get the final row echelon form, I just take R3 minus R3. And that's going to give me pretty much the same thing. 1, 0, 2/3, 1/3, 0, 0. And then 0, 1 minus 2. And then 0, 1/2, 0. And then 0, 0, 0. 1, 0, minus 1. Uh-oh, made a mistake. Minus 4R2 plus R3. I forgot to take the minus 4 on this one, so this is going to be minus 2. Sorry about that. Let's go back and fix that. Where's my, sorry, didn't catch. So this should be here when I took minus 4R2 plus R3. Didn't take this one, so that should be minus 2. Sorry about that. Now, if I had not caught that at that time, when I checked, I would have found it. So let's go back and fix this one. This one also is going to be plus 2. And then this is going to be minus 1. All right. So here's my matrix. Now, remember you have your C and your K and your L and all that stuff. Now, how does this matrix divide up? Well, it divides in half this way, because your original division was like this. And then notice your zero matrix down here. Now, notice you have to get all zeros here. Then we have this. All right, so that's my division. And here I've made, so let's look at part B. Okay, and my matrices here are my C, I think this is called C in the top corner. And I think this one's called K. And this one's called L. All right, now for part B, find matrices, rows, linear independence, null space equal to n of A, we need to remember that n of A is equal to n of C. And we know that the rows here are linearly independent. You can actually see that because there's no linear combination of these two rows that's going to give you 0, 0, 0. If I have a non-zero multiple of the first row, then the first coefficient is going to be non-zero. If I have a non-zero multiple of the second row, second coefficient is going to be non-zero. So the rows of C are linearly independent. So the answer to part B is the matrix C, which is simply 1, 0, 2/3, and 0, 1, minus 2. Okay, so that's the answer to part C. Now there's not, as far as I know, there's not a, well, you can actually check this. You could find a vector in the null space. For instance, one vector in the null space here would be 2/3, 0, minus 1. So let's do the check. I'm sorry. So let's see. The check would be find the vector in the null space. And that's going to be equal to span of, now it turns out there's only one vector that spans the null space because there's only one free variable. Now I choose x3 equal to minus 1, then x1 would be 2/3, and x2 would be minus 2. Now you can check that this vector is in the null space of A. Or now we can multiply this by 3 to make it a little bit easier, or we could say 2 minus 6 minus 3. And you can check and see if that's in the null space of A. Let's see. 2 minus 6 minus 3. If I take, let me just write it in red up here, 2 minus 6 minus 3. And I'll erase this later. Check that, in fact, this matrix A times this vector here is going to give me, well, if I do the first one, I'm going to get 3 times 2 is 6 plus 0, minus 6 is 0. Look at the next one, you're going to get minus 12 plus 12 is 0. Last one, you're going to get 6 minus 24 plus 18 is 0. So that checks out, and that gives me 0, 0, 0. So in fact, I am getting a vector in the null space. Looks like null space of C is equal to null space of A. So that's a good check. All right, now, next problem was find a matrix whose null space is the row space of A transpose. Okay. So let's take a look at the, well, you have to look at the properties. And the properties say that the matrix L is a matrix whose null space is the row space of A transpose. So part C, matrix L and I don't know exactly which theorem that is, but I would have hoped that you put that on your cheat sheet. So we know that the null space of L is equal to the row space of A transpose. Let's see if that's right. Okay. All right. So let's see if that works. Let's check it. Here my L was what? L was, where is it? 1, 2, minus 1. Okay. Now, the row space of A transpose is equal to the span of the columns of A transpose. Okay, I'm sorry. Let me say that again. Span of the rows of A transpose. Let's do it right. And that's equal to, actually the rows of A transpose are just going to be the columns of A, but in the other order. So I'm going to have 3, 0, 3 is the first one. Second one is going to be 0, 2, 4. Third one is going to be 2 minus 4 minus 6. Okay. Now, let's check that these are in fact in the null space of L. That these vectors are in the null space of L. All right, so check it by multiplying. First, we'll take L times the first one, 303. So when I do this product, what do I get? Well, inner product of this is going to be 3 plus 0. And this was a 3 down here. It looks kind of bad. But, so that's minus 3 is equal to 0. Now notice the result is a 1 by 1 vector. So you do get all zeros here. So this is in the null space. Okay, so let's do the next one, 1, 2 minus 1 times 0, 2, 4. Now in this case, I'm going to get 0 plus 4 minus 4 is equal to 0. So that result gives me 0. Again, this is 0 vector. It's a one-dimensional vector, but it's still 0 vector. And then finally, let's do the last one, 1, 2 minus 1 times 2 minus 4 minus 6. And that gives me 2 minus 8 plus 6 is equal to 0. So that checks out also. Okay. So the L equals 1, 2 minus 1 is my answer. So this would be my answer right here. Let's just highlight it this time. Right. So that's the full answer. I think there's nothing more to the problem. So that was the first answer, and then I'm sorry, the first answer was here, and the second answer was this one, and we checked and made sure that our answer was correct, and that's it.